I'm going to look at the practice test and go through the solutions for those of you that would like to get some more detail than just the answers. So for the first question, you were to assume that the rate of change was constant and then determine what the next point would be. So on something like this, I would count up and over, and I hope you can see the little dots here, but you can follow along on the actual practice test where there are grids. If I go up 1, 2, 3, 4, and then over 1, 2, 3, so up 4 and to the right 3. If I go up 1, 2, 3, 4 here and over 1, 2, 3, you can see that there is a constant rate of change here. So if I keep going in that pattern, up 1, 2, 3, 4, I would be up here at 8. And then 1, 2, 3 puts me over here at 2. So I would have a point here at 2, 8. And that is the answer for the next point to the right. For question number 2, you are to look at the given line and determine what the slope is. So again, we're going to do rise over run. And if we start over here, our rise is negative because we're going down. So down 1, 2, 3, and to the right 1, 2, 3, 4, 5, 6, 7. So that is to the right is the positive direction and down is to the negative direction. So for my rise over run, I was going down 3 and to the right 7. So my slope would be negative 3/7. Number 3 asks us which slope has an undefined, which graph has an undefined slope. And we're looking for, again, slope is always rise over run. And you have this information in your notes, but you can kind of intuitively think about this. Undefined happens when you divide by 0. So that means that you have a rise, but the run is 0. So like for line A, it doesn't have a rise, but it has a long run. A diagonal line is not going to have a slope that is undefined. And so line C, it has a rise. It's going up and down, but it doesn't change left or right. So its rise would be 0. So that's what's undefined. So for this one, our answer is line C. Vertical lines have slopes that are undefined. For question 4, which graph has a slope m of 1/3 and goes through the point -2, 2? So usually I go to find the point first. So -2, 2, that is, here's -2 for an x and up 2 for the y. So we're really deciding between line H and line O. And then, so we're looking at the slope. So this slope for H is going up 3 and over 1. So that is not a slope of up 1 over 3. So this is a slope of 3. I can even mark that on there, up 3 over 1. And so this one has an m of 3 over 1. But if I look at the red line O, if I go up 1, then I am going over 3. So up 1 over 3, up 1 over 3. That has a slope of 1/3. So line O is our answer. We'll take a look at the last two. So for number 5, you're identifying the graph that has the following equation. Y equals -1 times the quantity x plus 3 minus 4. The first thing I do when I'm looking at equation is I try to pull out the point, that stealth hidden information in there, and determine the slope. So slope is always the number that is multiplied by x, often that is outside of parentheses in point slope form. It's always this first number. So my slope is -1. You could also think of that as -1 over 1. And my point, remember, I'm looking at these two values, and it's the opposite of what you're seeing in here. So instead of +3, our point is -3. And then for the y value, it's what's outside, and it's exactly as you see it here of -4. And that is because the point slope form equation is of the form y equals m times x minus x1 plus y1, where x1, y1 is our point, and this negative that's built into our form makes this become the opposite of what you see, and this stays exactly the same. So this is our point that we're looking for, and this is our slope. So if we're looking at our graphs that are given, if I go to -3 for the x coordinate and I go to -4 for the y coordinate, there is really only one choice here. But it does match that we have a -1 slope, down one, right one, or up one, left one. So line S is our choice here. And taking a look at number 6, we are looking at writing an equation for the line shown. So again, I'm going to still look for that same information of a slope and a point. And we have many points that we could look at here. We have, well, let's start with slope. So if I start here, I have a coordinate of -6, -4. This point right here is -4, +1, and this point right here is -2, 6. So those are the three coordinates that we're working at. And if we're counting our rise over our rise is 1, 2, 3, 4, 5. Oops, went too far. So 1, 2, 3, 4, 5. There we go. It was 5. So up 5, and then to the right 2. It still matches here, 1, 2, 3, 4, 5, and to the right 2. So our slope here, rise over run, is going to be 5/2. And then we have many points. And so let's take a look at each of these points, and we'll write an equation for each of these points. You only have to write one. So if I take this point down here of -6, -4 as my point, my equation would be y equals 5/2 and then x. And if I'm subtracting a -6, that's the same thing as adding 6. And then I'm adding a -4, which is the same thing as subtracting 4. And if we look back at our form here, we just know that this should be the opposite sign of what we see in our parentheses with x, and this should be the same, and that does match up. So if I take that middle point of -4, 1, we could write the equation y equals 5/2. This is going to be x, and you're subtracting -4, which is the same thing as adding 4, and then adding 1, so that would be +1 right there. And we could even do that last point, which I guess I will squeeze in up here just for lack of planning on my part. -2, 6 is the point that we're thinking of, and that would be y equals 5/2. X minus -2 makes x +2 in our parentheses, and then it would be plus this y value, which is 6. So these are three possible equations for this line. You could use all of them or any of them. Just you only have to give one.